Hello everyone. Today we will see one of the concept which is used to evaluate the limit. It is indeterminate form. Indeterminate form means we can't determine the value of that function. So first we will see the definition and we will think which are the functions which we can't determine the values and why it is not to be determined, or if we take the value what's happen. Okay. So indeterminate form means let f of x and g of x be functions of x such that f of a equal to 0 and g of a equal to 0, means f of x and g of x are functions which has value 0 at point a. Then the ratio limit x tends to a, f of x upon g of x is called determinant forms, or you may call f of a upon g of a, that is 0 upon 0, is called indeterminate form. So limit x tends to a, f of x upon g of x is called indeterminate form. So there are 7 such forms. The first one is 0 upon 0, infinity upon infinity, 0 into infinity, infinity minus infinity, 0 raised to 0, infinity raised to 0, and 1 raised to infinity. So 7 such forms are there. Now you can see, or you can observe here, infinity upon infinity also I can write in terms of 0 by 0, because infinity means 1 upon 0. The value of infinity is 1 by 0. So infinity upon infinity means again 1 upon 0, 1 upon 0. So I can write 0 upon 0. Same way here, infinity 1 upon 0. So it becomes 0 upon 0. Infinity minus infinity, it is also again 1 upon 0 minus 1 upon 0. So I get 0 upon 0. Then remaining 3 parts, 0 raised to 0, infinity raised to 0, 1 raised to infinity. If I take a log of this, then I get either infinity by infinity or 0 by 0. So all remaining 6 forms we can convert in 0 by 0. So this is our basic form 0 by 0, and all other forms, indeterminate forms, we can convert into 0 by 0. Now the question is, what's happen if I take the value of 0 by 0 is some constant? Just like I can cancel 0 by 0, so 0 by 0 is 1 if I take in that way. Then what's happen? I will show you with some example, little bit small example we will take to understand the concept. Suppose I take here x is equal to y. I assume any two values x equal to y. Now I multiply it by x. So I get x square is equal to xy. Isn't it? X square equal to xy. Now subtract y square both sides. X square minus y square is equal to xy minus y square. Y square we subtracted both sides. Now here x square minus y square is nothing but x minus y and x plus y. The value of x square minus y square is x minus y, x plus y is equal to, here y common, so y in bracket x minus y. So I get here x plus y is equal to y x minus y upon x minus y. So I can cancel x minus y, isn't it? This get cancelled. So here x plus y is equal to y, but value of x is y, which we have assumed. So here y plus y is equal to y. So 2y is equal to y. Now we can cancel y. 2 is equal to 1. So our mathematics get collapse. 200 is equal to 100. 2 lakh is equal to 1 lakh. Our whole mathematics get collapse. And now there is nothing wrong in this statement, in the steps. If I take x equal to y, x square equal to xy, like that we proceed and we get 2 equal to 1. You can try yourself. Then you will realize it. Now here, what is the wrong statement, or what is the difficulty? Difficulty is this term, x minus y upon x minus y, because the value of x minus y from very first step x minus y is 0, value of x minus y is 0. So it is 0 upon 0, and I cancel 0 upon 0 means I take some value or one value for this, right? Means I can't cancel 0 by 0. I cannot able to I'm not able to cancel 0 upon 0. So 0 upon 0 is indeterminate, because if I take the value, my mathematics get collapse. So that's why this function, this situation or 0 by 0 condition, we called it as indeterminate form. So there are 7 such forms. Keep in your mind, to use our L'Hospital rule, we have to convert other forms into 0 by 0 or infinity by infinity. So what is that L'Hospital rule? So the function f of x and g of x be two functions such that f of a equal to 0 and g of a equal to 0. Or you may take f of a equal to infinity or g of a equal to infinity. Then limit x tends to a, f of x upon g of x. See carefully, limit x tends to a, f of x upon g of x is equal to limit x tends to a, f dash of x upon g dash of x. Means we are going to take derivative with respect to x, derivative with respect to x, numerator and denominator separately, right? And for that we must have either 0 by 0 or infinity by infinity form. Mostly we prefer 0 by 0. Okay, rare case we may use infinity by infinity. Now we know the some standard results, that is limit x tends to 0, sin x upon x is 1. Same way tan x upon x is also 1, limit x tends to 0. Same way sin inverse x, and we can write many more. So mostly we required sin x upon x, tan x upon x, 1 plus x raised to 1 by x, it is e like that. Okay, I will show you some examples to get this concept completely. Suppose I have to evaluate limit x tends to 0, 1 plus x raised to n minus 1 upon x. Clearly. Now here, if I put x equal to 0, carefully we will, roughly we can do it. If I put x equal to 0, I get 1 raised to n. If n is real number, no problem. Either one root is 1 there. So here 1 power 1 raised to n. So here 1 minus 1 upon 0, right? So it is 0 by 0. So it is the condition for L'Hospital rule. 0 by 0 is there, then we can use L'Hospital rule. So by L'Hospital rule, we will get limit x tends to 0. Take the derivative of numerator separately. Now 1 plus x raised to n, it is n into 1 plus x raised to n minus 1, and derivative of minus 1 is 0 upon derivative of x is 1. Separately we take, no u upon v rule. Separately, numerator separate, denominator separate. Now you can put x equal to 0, you will get your answer n. You may try for the next example. Suppose I take a raised to x minus 1 minus x log a upon x square, limit x tends to 0. Now here, if I put x equal to 0, I get a raised to 0. A raised to 0 is 1 minus 1 minus x equal to 0 means this term is 0 upon 0, right? So it is 0 by 0. So by L'Hospital rule, what will you get? Derivative of a raised to x, here limit x tends to 0, derivative of a raised to x is a raised to x, derivative of a raised to x is a raised to x into log a, derivative of 1 is 0 minus derivative of x is 1 log a upon 2x. Now again, if I put x equal to 0, a raised to 0, that is 1, log a minus log a, that is 0 upon 0, again 0 by 0. So again by L'Hospital rule, limit x tends to 0, I get here a raised to x into log a square. Derivative of a raised to x is a raised to x into log a and previous log a, so it becomes log a square. Derivative of log a is 0 upon 2. Put the limit x equal to 0. Our answer is log a bracket square upon 2. So in this way we can find the answer. We will take some more examples to understand the concept. Suppose I take this example. Limit x tends to 0, evaluate we have to limit x tends to 0, 2 raised to x minus 3 raised to x upon x. So again here if I put x equal to 0, I get 2 raised to 0, that is 1 minus 1, that is 0 upon 0. So 0 upon 0, use L'Hospital rule. Numerator, derivative of numerator separately, 2 raised to x log 2 minus 3 raised to x log 3 upon derivative of x is 1 and limit x tends to 0, we will get answer 2 by 3. Like that we can solve the problem. Now we will take the example to find the values of a and b if some limit is given. So here find a and b if limit x tends to 0, a cos x minus a plus bx upon x raised to 4 is equal to 1 by 12. Here denominator is x raised to 4, so keep in your mind that you have to take that many times, you have to use that many times L'Hospital rule. Okay, now I can call this LHS, that limit, as a L. So L is equal to limit x tends to 0, a cos x minus a plus bx upon x raised to 4. Now if I put x equal to 0, I get cos 0 is 1. So a minus a, 0 plus 0. So here 0 numerator upon x equal to 0 means denominator 0. So it is 0 by 0 by L'Hospital rule. By L'Hospital rule what will we get? Limit x tends to 0, a as it is, derivative of cos x is minus sin x, derivative of a is 0 plus here derivative of bx is b upon 4x cube, isn't it? 4x cube, right? Now sin 0 is 0 but b is not equal to 0, so numerator does not become equal to 0 but denominator is 0. But to use L'Hospital rule we must have numerator also 0, so we take numerator is equal to 0 minus a sin x plus b equal to 0 to find value of b. This must be 0 at x equal to 0, at x equal to 0. So put x equal to 0. If I put x equal to 0, I get sin 0 0 plus b equal to 0. So I get the value of b equal to 0, right? Now here I assume that this numerator is 0, right? Denominator is already 0, so I get a 0 by 0 form. So by L'Hospital rule, again minus a, derivative of sin x is cos x, derivative of b is 0 upon 12x square. It is again 0 by 0, you can check. Minus a cos x we get, it is not equal to 0 by 0. It is not 0 by 0 because cos 0 is 1. So I get here numerator upon denominator. Denominator is 0. So I have to take minus a cos x is equal to 0. So again a equal to 0 we get in this case. Something is wrong. We will solve it again.